Dear students, welcome to the third part of the lecture, Introduction to Engineering Graphics. This part covers two topics. One is perspective projection and the other one is conversion of pictorial views into orthographic views. What is perspective projection? To get the concept of perspective projection, let's look at these pictures. The first picture is a real life picture and the other one is a famous painting by Da Vinci. If we observe these pictures closely, we can see some interesting facts. Let's go to the first picture. In this picture, in reality, we know that these rails are parallel to each other, but if we draw lines through these rails and also through the ends of these sleepers, you can see that this line will converge to a single point somewhere here. And also you can observe that the size of these sleepers is reducing when we move further. Let us see the painting. Here also you can see the similar fashion. The lines drawn here is converging to the forehead of the Jesus. We can get so many examples in real life. All these lines will converge to a single point. This is what actually we can see in reality. So, we can conclude that the perspective projection gives the most realistic view of an object. Also, it is a pictorial view of an object as seen by the human eye. It shows an object as it appears instead of showing its true shape and size. So, in perspective projection, we never get the true shape and size of an object. It is just a pictorial view of the object. Now, let us discuss the comparison between orthographic projection and perspective projection. In the first two parts of the lecture, we have discussed multi-view projection and isometric projection. Both these projections are orthographic projection. In these two projections, the observer is placed infinite distance from the object, and you can see that all the projectors are parallel to each other and perpendicular to the plane of projection. So, in orthographic projection, whether it is multi-view projection or isometric projection, the relative position of the observer, object and the plane of projection are insignificant. But in perspective projection, the relative position of observer, object and the plane of projection are very important. The observer is at finite distance from the object. The visual rays, or we can say it is projectors or line of sights, will converge at the observer's eye, or it is also called a station point. So, I can see from the figure there is a projection plane, the object is placed behind the projection plane and the observer is always in front of the projection plane. If the object is placed behind the projection plane, you will get a lesser size object in perspective projection. So, if the object is placed on the picture plane, you will get the true shape of the true size of the object in perspective projection. So, obviously, if the object is placed in front of the projection plane, you will get a larger size image on the picture plane. Now, we will discuss the elements of perspective projection. These are the important elements of perspective projection. First one is the ground plane. The ground plane is a horizontal plane on which the object and the observer is assumed to be placed. The second plane is the picture plane. It is a transparent vertical plane on which you will get the perspective view. The third plane is the auxiliary ground plane, which is a horizontal plane parallel to the ground plane. Sometimes the object is placed on this AGP, auxiliary ground plane. The next one is station point. The station point is the location of the observer's eye, which is always above the ground plane and in front of the picture plane. The other plane is horizon plane. It is actually a auxiliary ground plane, but it is passing through the station point. So, horizon plane is used to locate the front view of the station point. The last plane is a vertical plane, which is called a central plane, which is perpendicular to both the ground plane and the picture plane, but it is passing through the station point. So, central plane is also used to locate the station points location from the with respect to the object. Now, this system together is a 3D system. We know the perspective projection is a pictorial representation of a 3D object into a 2D plane. So, we need to convert this system into 2D plane. So, here to convert this 3D system to 2D, we just draw the front view and the top view of this system as we have already discussed in the first two parts, that is like orthographic projection. So, in front view you can see the ground plane as a line. So, we draw the ground plane as a line first, then we can see the horizon plane also as a line which is parallel to the ground line, which is at a distance above the ground line, exactly at the height of the observer. Now, you can see the object's front view in the front view direction. So, you can that object is always placed above the ground plane, or sometimes it is resting on the ground plane. So, the elevation or front view of the object is always above the ground line. Now, in top view you can see the picture plane as a line, and also the top view of the object. Depending on the position of the object, you can see the top view of the object above the PP line or below the PP line, or sometimes the topi of the objects may cross the PP line. So, you can place the object in front of PP, behind PP, or the PP may cross the some points of the object. Now, we need to locate the station points front view and top view. To locate the station points front view and top view, we need to locate the central plane, because the central plane is passing through the station point and it is perpendicular to both PP and GP. So, the central plane is always represent with respect to the objects. So, depending on the position of the central plane with respect to object, you will get the central line. In front view you can, and also in top view you can see the central plane as a line which is perpendicular to both PP line and ground line. So, to locate the station points top view, the station point is always in front of the picture plane. So, the distance from the picture plane to the observer is marked on the central line which is below the PP line. That will be the station points top view. Now, you can, to locate the station points front view, the meeting line of central line and the horizon line, because will give you the station points front view. This completes the conversion of 3D system into 2D system. See, depending on the location of the central plane or observer from the object, you can draw the central line in different positions. So, depending on the position, you will get the station points front view and top view accordingly. These are some points to note here. The horizon plane referred with the ground plane always, and it is always above the ground plane. The height of the observer equals the height of the horizon plane. So, front view of the station point is on the horizon line. The next point is the distance of the observer from the picture plane PP represented as topi of the station point. So, topi of the station point is always below the picture plane, because the observer is always in front of the picture plane. The central plane referred with respect to some point on the object always. So, front view and top view of the station point is lies on the central plane or central line. Now, to draw the perspective projection, there are two methods. The first method is visual ray method and the other one is vanishing point method. We are discussing visual ray method only here. Let us discuss the visual ray method by solving this problem. A regular triangular prism of 40 mm side of base and axis 80 mm lies on its rectangular face on the ground. A triangular base is parallel to and 15 mm behind PP. The observer is viewing the object from a point 50 mm above the ground plane and 30 mm in front of the picture plane. The central plane is 90 mm towards the left of the axis of the prism. Draw the perspective view of the prism. So, this is the problem. is a triangular prism. So, it is resting on the ground plane like this. So, you can see a triangular prism, it is resting on the ground plane. Its axis is perpendicular to the picture plane, and the front triangular base of the prism is parallel to the picture plane, and it is 15 mm behind PP. So, this is the position of the object. So, you can see in front view, you can see the true shape of the triangular base, and in top view you can see the height of the prism. So, depending on this, first we can draw the front view of the ground line, front view of the ground plane. Then we can draw the horizon line, which is 50 mm above the ground line. It is given that the observer is 50 mm above the ground plane. So, the location of horizon line is 50 mm above the ground line, because horizon plane is passing through the station point. Now, you can draw the front view of the triangular prism, that will be the true shape of the base. Okay. So, this triangular base you can see in front view directly. Now, you can draw the top view elements, that is the picture plane first. The distance between the picture plane and the horizon line should be more than that of the station point's top view, more than that of the distance of the distance between station point and the picture plane. Also, you can draw the top view of the solid behind the PP. It is given that the object is placed 15 mm behind the PP. So, you can see top view of the object is this one. Okay, you can see the height of the triangular prism directly in top view, and also the triangular base, the front triangular base of the prism is parallel to PP and is 15 mm behind PP. So, this will be your top view and this will be your front view. So, I have named it, the front triangular base is named as ABC, and the top behind triangular base is named as 1, 2, 3. Now, we need to locate the station points front view and top view. So, that it is given that the central plane is at a distance 50 mm above the ground line. We already draw that location in the horizon line. So, you can see here it is given that the central plane is 90 mm to the left of the axis of the object. So, you can draw the central line which is 90 mm from the axis of the object. Okay. So, this is your central line. So, the meeting point of central line and the horizon line will give you the station points front view. To find the top view, it is given that the observer is at a distance 30 mm in front of the central plane. So, I have marked 30 mm below on central line. You will get the station points top view. It is denoted with S. Front view of the station point is denoted with S dash. Now, to draw the perspective view in visual ray method, these are the steps. First, we need to draw the visual rays from front view of the station point towards the front view of the object. So, S dash A dash, S dash B dash and S dash C dash are the front view visual rays to the triangular base, front triangular base, and these visual rays represents S dash 1 dash, S dash 2 dash and S dash 3 dash represent the visual rays of behind triangular base 1, 2, 3. Now, we need to draw the visual rays in top view. So, to find the perspective point of A, draw the visual ray in top view from S to the point A, and from the intercept of this top view visual ray and PP, you draw a vertical projection line to the corresponding front view visual ray, that is S dash A dash. You will get the perspective point of A, perspective view of point A. Similarly, you can find the perspective points of point B, C, 1, 2 and 3. Once you got all these perspective points, now we need to join all these points. You will get the perspective view of the triangular prism. So, to join all these points, there are some rules. First, draw all the boundary lines of this object. So, these are the boundary lines AB, BC, C3 and 3, 1. Now, the next rule, okay, there are 1 point remaining here and 3, 2, 1, 2, 2B and AC, that are the edges remaining here. So, the second rule is, after joining all the boundary lines, see the front view of the object from the S dash and also from the point S, that is the top view of the station point, look to the top view of the objects. The line or a point which is nearer to the station point will be visible in the perspective view. So, the line AC is nearer to the station point's top view, and also you can see the line AC is nearer to the station point's front view. So, you can mark this line AC as a visible line. Now, the next rule is, if a line is crossing a visible line within the boundary of the perspective view, we will be the hidden line. So, here you can draw the line 2B as a hidden line because it is crossing a visible line AC. The last rule is all the lines joining a point within the boundary of the perspective view will be either visible or invisible. So, here the point 2 is invisible because 2B, the line 2B is invisible. So, all the lines joining 2.2, that is 3 2 and 1 2 also will be invisible. So, this completes the projection. So, now these are the rules to find the hidden and visible edges. We have already discussed this. Now, we can conclude the steps to draw a perspective projection by using a visual ray method. First, draw the ground line, then draw the horizon line. It is above the ground line by the height of the observer. The third step is draw the top view of the picture plane, then the height of the picture plane above the horizon line should be more than that of the distance of the observer from the picture plane. Draw the front view and top view of the object based on the position with respect to PP and GP, picture plane and ground plane. Then locate the position of the center line, central plane with respect to the object and represent it as a perpendicular line with both PP and GL, PP line and ground line. On the center line, mark the top view of the station point and front view of the station point based on the position with respect to PP and GP. The distance SP dash measured from the ground line upward always, because the observer is always above the ground plane. The distance SP measured from PP line downward, because the observer is always in front of the picture plane. Now, draw visual rays from SP dash to all elevation points of the object. Then draw the visual rays from SP, that is top view of the station point, to all the plant points, top view of the top view points of the object, and note the intercepts of each line with PP. From each intercept with PP, draw projectors vertically to meet the respective front view visual rays to get the perspective points. They are denoted with capital letters A, B, C, D, etc. By joining all these points, you will get the perspective view of the object. Now, the second part, conversion of pictorial views into orthographic views. In the first two parts, we have already discussed quadrant systems to represent a 3D object to a 2D plane. We have some reference planes. We already discussed the two reference planes, first two parts. Sometimes we need to represent the side view of the object also. So, in front view, you can mark the front view on the vertical plane. You will get the top view of the object on the horizontal plane. We need to represent the side view. We have an extra reference plane that is called PP. Here it is not picture plane, it is called profile plane PP. So, this PP is perpendicular to both vertical plane and the horizontal plane. Now, we follow the first angle projection. If the object is placed in the first quadrant, then it is called a first angle projection. On the VP, you will get the front view of the object. On HP, you will get the top view of the object, and on the PP, you will get the side views. Here, the PP is right side of the object. So, this view is the left side view of the object. So, the left side view of the object is always on the right side picture plane. Now, to make it 2D, you rotate the horizontal plane clockwise downward and the picture plane towards the right side of the vertical plane. That is, we are opening the first quadrant. So, you will get we will get the orthographic views, front view, top view and side view of the real object. This is the front view, this is the top view and this is the left side view of the object. There is another example here. The front view, top view and side view directions are given in this picture. So, in the front view, you can see this is our front view. So, this plane and these planes you can see directly in front view, and also in top view you can see this face of the object, this face of the object and this face of the object. Okay. And in side view you can see this face and this face. Finally, you will get the conversion of pictorial view to the orthographic view, the front view, top view and the side view. So, with this I conclude. Thank you all.